Hi there. So far, we have seen these laws of chemical combinations. It is time to move ahead. Well, chemistry is a science of patterns, and in early 1800s, one such pattern sparked immense curiosity. Well, gases, when they reacted, did so in simple volume ratios. This pattern was carefully observed and described by the French chemist Gay-Lussac. According to this law, we know that gases combine or are produced in a chemical reaction in simple whole number ratios by volume, provided all gases are at same temperature and pressure, right? And if you remember, we applied this law in the formation of water vapor from hydrogen and oxygen. So according to this law, if we say that two volumes of hydrogen combines with one volume of oxygen, we saw experimentally that two volumes of water vapor was formed. But there was no explanation provided for this experimental observation. It was in 1811 that Avogadro, an Italian physicist, stepped in with a revolutionary idea. He proposed equal volumes of gases at the same temperature and pressure should contain equal number of molecules or particles. Well, at first glance, it sounds straightforward, isn't it? But this one line explained all of Gay-Lussac's mysterious volume ratios. It kind of like provided a bridge between what we observe, that is volume, and what actually exists, that is number of molecules. So if I have to write this mathematically, I can simply say volume is directly proportional to number of molecules, where the small n signifies the number of molecules or number of particles. Okay. Now let's unpack this with this example. Okay. Imagine what we have here are three identical balloons. One is filled with helium, which is a monoatomic gas. The other one is filled with nitrogen, which is a diatomic gas. And the third one is filled with methane, which is a pentaatomic gas, as there are 1, 2, 3, 4, 5 atoms. So let's just simply call it a polyatomic gas. Now, if these balloons are all at the same volume, held at the same temperature and pressure, which one has more gas? The intuitive answer might be helium is lighter and smaller, so maybe more of it fits in the small space, right? Or perhaps you're thinking methane is heavier and bulkier. Surely fewer of those molecules fit in a balloon of the same size. But Avogadro's law tells us otherwise. All the three balloons contain the same number of gas molecules regardless of their mass or size, because the volume of a gas, like I said, is directly proportional to the number of molecules, not their size or type. This was a turning point in how we understood gases. For the first time, scientists had a molecular explanation for Gay-Lussac's volume ratios. Now let's return to our example of water formation, right? So here we learned that how two volumes of hydrogen and one volume of oxygen combine to form two volumes of water vapor. This is what we found experimentally, and this can now be explained beautifully using Avogadro's idea. So according to Avogadro, two volumes of hydrogen gas contain how many molecules? We can say that it contains 2n molecules. Similarly, one volume of oxygen contains, let's say, n molecules of oxygen. They combine to form two volumes of water vapor, which contain 2n molecules of water vapor, right? So this explains how we get 2:1:2 volume ratio corresponding to the molecular ratio, right? Because like we understood, V is directly proportional to N according to the Avogadro's law. Well, now that you've understood volume is directly proportional to the number of molecules at the same temperature and pressure, I have a question for you. Let's try to apply this law here, okay? Say I experimentally give you the volume ratio of the formation of ammonia from hydrogen and nitrogen to be 3:1:2. And I tell you that number of molecules, though let me tell you, number of molecules will be way more, but this is a hypothetical situation I'm giving you so that you can apply the law better. So here you can see that I have 4 molecules in this container. Now, I've also given you the experimental volume ratio of 3:1:2. So, if you know the number of molecules of ammonia, can you find out the number of molecules of hydrogen and nitrogen that would have reacted to form these 4 molecules of ammonia? Let's see if you can apply Avogadro's law. Pause the video and do try this question. I hope you could do it. So we know volume is proportional to the number of molecules as per Avogadro's law. So if the volume ratio is 3:1:2, so is the molecular ratio. So molecular ratio is also going to be equal to 3:1:2. Now number of molecules of ammonia are 4. So that means it's just the double of 2. So that means the number of molecules of hydrogen should also be the double of this number, that is 3 into 2. 6 molecules should be there of hydrogen, and 1 into 2, that means 2 molecules of nitrogen should be there. Let's check. There you go. We could apply Avogadro's law very well. You can see if 4 molecules of ammonia are in the container, that must would have been formed after 6 molecules of hydrogen reacted with 2 molecules of nitrogen. That's when we will get 4 molecules of ammonia. Now that we know how to apply Avogadro's law, let's take a look at a question. The question says, what would be the ratio of total number of atoms present in 10 liters of oxygen and 5 liters of methane at the same temperature and pressure? Total number of atoms we have to find. Pause the video and do try this question. Okay, I hope you could do it. So we have oxygen and we have methane. Oxygen is 10 liters and methane is 5 liters as per the question, right? Let's first see the volume ratio. What's the volume ratio? It is 2:1, and the same ratio has to be of the molecule. So I can say the molecule ratio is going to be equal to the same 2:1. Now remember, this is the molecular ratio and not atomic ratio. How many atoms are there in oxygen? 2 atoms. Okay. And how many atoms are there in methane? 4 and 1? 5. 5 atoms. So we had to find the total number of atoms present and the ratio of the total number of atoms present. So we can say for oxygen, if I'm talking about the atoms, then I have to multiply 2 into 2, that is 4. And for methane, I have to multiply 5 into 1, that is 5. So 4:5, that is option number C becomes the answer to this question.